So again, let's start from the client perspective. So we have the client, and the client in the end wants the underlying products or the idea of the underlying products. So similarly, then what we'll have some interface or abstract class for the underlying product. But this time we won't have just one product, we'll have multiple products. So we can imagine that over here we have two different products. Let's call this one over here product 1, and let's call this one over here product 2. The client in the end, like we said, wants a concrete object of type product 1 and product 2, but it doesn't care about the actual concrete instances. All it cares about is that they're from the same family, meaning that both of them are, let's say, buttons from macOS or buttons from Linux or buttons from Windows. You'll care about this being, let's say, a checkbox and this just being a regular button with the functionality that comes with that object, but it doesn't care about the underlying implementation. All it cares about is that it comes from the same family. So like we said, what we have is we have an abstract class, and this will be the abstract factory. The abstract factory will know how to create these objects. So over here, we'll have create product 1, and this entire thing will return product 1, and it'll also have create product 2, which will go ahead and create product 2. Meaning that over here, we also have a line, let's say over here again, creates. Let's make this entire thing a bit smaller, just so we have more room for the concrete products. And over here, we also need a line that the client goes ahead and uses the abstract factory to create the underlying products. Now, of course, having only the abstract classes and the interfaces isn't enough. We need the concrete types as well. So let's go ahead and add over here the concrete product 1. And alongside this, let's also add here the concrete product 2. These two objects, they implement the interfaces, all right, for the product 1 and product 2. But of course, we don't have to have only one. The entire idea is that over here, we can have multiple different concrete products of each type. Likewise, we also have the concrete factories. So let's say over here, concrete factory. And the concrete factory, of course, needs these two methods as well. The concrete factory extends the abstract factory. And I see I have the arrows the other way around for the implements. So let's fix that as well. So I updated the arrows to point to product 1 because the concrete products, they go ahead and implement the interface and not the other way around. Okay, so overall what we have is the client uses the abstract factory, which knows how to create the two underlying products, but in runtime, it does it via the concrete factories. Now, there isn't only one concrete factory, but there are potentially multiple concrete factories. Now, we may say that these two concrete products are part of one family, and these two concrete products are part of another family. To illustrate this, let's go ahead and put a line over here around these, and let's make the line something like this. And likewise, we have another one over here for these two concrete products. Let's say that all of these are part of family A, and these over here are part of family B. And then what we may have is we may have over here the two concrete factories where this one over here knows how to create the products in family A, and this one knows how to create the objects from family B. Now, of course, the separation doesn't have to be total. So you may have objects that overlap inside them. Each one of the factories needs to know how to implement the abstract factory with a collection of objects that make sense together. So just to complete this example, let's add a line over here between this concrete factory and this family, and let's add another line from this concrete factory to this family, representing that this knows how to create this family and this knows how to create that family. So overall, what we have is the following. We have the client, which cares in the end about families of objects. So it cares about either these objects over here or about the objects in family B. Now, to get hold of either these objects or these objects in a way that is safe when you know the objects won't mix with one another, then it's using the abstract factory pattern. The abstract factory pattern goes ahead and defines an abstract class which has the methods. Now I'm saying abstract class, but this can also, of course, be an interface. The client just uses something abstract to create the underlying products without caring about how this is implemented. Then in runtime, it uses either this concrete factory or it uses this concrete factory. Whichever one it has in runtime, it knows will create only products from its corresponding family. So the concrete factory will go ahead and create either these objects or these objects, and it won't mix between them. Now, also from the client's perspective, then it doesn't actually care about the concrete products, the types that they have. All it cares about the underlying behavior. So if we said, for example, it's a button, then it cares about the on-click method or the checkbox, being able to check it and uncheck it. For that, we have an interface for the underlying products. So the abstract factory goes ahead and returns these abstract products or these interfaces that expose the underlying behavior or the underlying product object that we want. So now that we have this class diagram, I want to make this abstract factory pattern a bit less abstract by looking at a concrete example. Welcome to Dome Train's quest number 2. Number 1 was such a great success and people had so much fun, so much enjoyment, and most importantly, it was so educational. So in Dome Train's quest 2, we're going to make things crazier and wilder. We're going to have again 2 levels. Level number 1 is the cave level, but this time it's not just going to be a goblin in a cave, but we'll also have various things that will help you power up and also weapons. As you can see, there is an axe over here. In level 2, we'll have a haunted house, and in the haunted house, we'll have to somehow go through it without hitting or without being eaten by these ghosts. But luckily, we have a weapon which we can use now to go ahead and defeat the ghosts. And also, we have something that will help us power up. Terms and conditions apply. Must be 18 or older to enter. Void where prohibited. See store for details. For complete rules, visit our website, www.rickroll.com. Okay, so recapping that odd experience that I just gave you, then in Dome Train's Quest 2, then we have again 2 levels, but in level 1, we don't only have the goblin, we also have a weapon and a power-up. The weapon is the axe, and the power-up is the crystal, specifically for the cave level. For the haunted house level, then the enemy is the ghost, same thing like in the previous design pattern, but we also have the power-up being this sort of orb, let's call it, and this mystical staff. Now, looking at the most straightforward implementation of something like this, then somewhere in our code, then we would need to go ahead and for level 1, create the goblin, the axe, and the crystal. For level 2, we would need to go ahead and create the ghost, the staff, and the orb. But what we have over here, again, is a direct dependency from the client code on the underlying elements in the game. So basically what we have is we have all these level elements that the client wants to use. The client, from its point of view, let's imagine that this entire thing is somewhere called the game engine. The client doesn't care about the actual enemy, weapon, or power-up. It cares about the idea of having an enemy, a weapon, and a power-up, because these are elements that you have in each one of the levels. The game engine, from its point of view, it cares about the underlying things that it needs to do with these elements, like draw them to the screen if we have, let's say, NPCs, then starting them, letting them wander around the level. The game engine thinks in that level of abstraction, and it doesn't care about if the NPC is a woman carrying her child or if it's an old person going to the store. The game engine cares about starting the NPCs. The game engine cares about starting or invoking or spawning the enemy, etc. Okay, so the game engine cares about that layer of abstraction. Now, to give the client this level of abstraction, then we can go ahead and use just the simple factory. So when we want an enemy, then all we need to do is use some factory which encapsulates the creation of the object. So we can imagine using the simple factory. Again, this entire thing is using the simple factory. We have these methods that each one of them knows how to create the corresponding enemy weapon, and power up. For the implementation, you can imagine just the naive implementation is that over here we pass the level number or something, and then based on the level number, then the game element factory knows which element to create. But the problem with this approach is that nothing stops invalid combinations, meaning that we are able to introduce by mistake a scenario in which you create combos that don't work. For example, a combo that does work is, let's say, the goblin and the axe. But a combo that doesn't work is a goblin and a wand. Nothing stops in this implementation having invalid combos. And that's because everything is contained inside the game element factory, and each one of these methods has its independent authority and freedom to go ahead and have custom logic for the creation of the underlying elements. Instead, what we can do is use the abstract factory pattern. What this would look like is we would go ahead and have a concrete factory per level where this factory knows how to create the correct elements, the correct game elements for the specific level. For example, for the cave level factory, then these methods will go ahead and create the goblin, the axe, and the crystal. For the haunted house level, then the create enemy will create the ghost, the weapon will be the mystical staff, and the power-up will be that orb. Now, I do want you to have in mind the client behavior, what the client will actually look like. So I also put over here some implementation for the client. Of course, everything we're talking about is an oversimplification of the complexity of writing something like this. But this is just to give you the intuition of each one of the components. So this is just to give you the intuition for how the client uses the abstract factory without caring about the underlying implementation. So we have the abstract factory, and behind this, then we have two factories. We have the cave level and we have the haunted house level. Each one of these knows how to create the various elements. Now, the game engine, from its point of view, it doesn't care which level it gets. So it can get this level and it can get this level, but from its point of view, it doesn't care as long as it implements the abstract factory. So the game engine knows that the level factory will go ahead and know how to create the NPCs, so it can go ahead and just start them. Likewise, it can go ahead and create the enemy, the weapon, the power-up, the obstacles, etc. And it knows that the family of products that it eventually has makes sense together. So it's using that one factory to create a family of related or dependent objects. And one of the important aspects that we touched a bit about is that you want the combos to work with one another. So for example, some weapons won't work with some enemies, not just from a logical point of view, but also in the underlying implementation of, let's say, the goblin, then it doesn't know how to handle some type of weapon. So when you go ahead and you combine these objects, let's say you call weapon.attack and you pass the enemy object or something like that, then you need the objects to know how to interact with one another. Okay, so now that we have an example that we can talk about and imagine, let's go ahead and create the class diagram for this example.